And let's say that the front face is 8 inches. The side here is 4 inches. And then this is 5 inches is the height. Do you know how to find the volume of a prism?
No.
No. Okay. So the volume of a prism is length times width times height. And the length is kind of arbitrary. The same with the width and then the height. And when I mean arbitrary, what I mean is that depending on how you orient this cube prism thing, you could call this the width, or you could call this the length, or this the height, and this the width, and that the length. You need 3 numbers though. You need the 3 dimensions of the prism. Is this something that you have seen before?
Yeah.
Okay, so we're going to just multiply the numbers together. Okay, can you multiply those 3 numbers together for me?
8 times 4
Yep, times 5.
times 5.
Yes.
It is 8, 4 times. So 20, and then that's 20. And
That's
then
right.
28.
So you're multiplying 20 times 8.
20
20.
times 8.
Yeah.
28.
So it's like saying 20 times 8, like this.
I actually don't know this problem.
Okay, what about 20 times 2?
20 times 2.
Yes.
That's 40.
40. So the extra 0, I'm sorry, I apologize here. So note, okay, let me do this differently. Sorry. So let's do 2 times 8. Do you know that?
That is 16, right?
16, yeah. So when you put a 0 here, you just add a 0 down here.
Oh.
Okay, so for example here, so if we go back to this problem, the volume is 160, but it's inches times inches times inches. So there's 2 ways you can write it. You can say inches to the power of 3 or inches cubed, or you can say 160 cubic inches.
Okay.
Okay, now we're just going to work on what we just did here, but we're going to do something. We're just going to go slight tangent. What is, let's go 30 times 5. Okay.
30 times
So,
5.
so to do this, what I really want you to do is first say to yourself, what is 3 times 5?
15, right?
15. And then this 0 just comes
Down.
down. Yeah. So what is 40 times 3? So again, like what you would do is you would think, oh, what is 4 times 3?
It's 12.
Okay, but because of that 0, you're going to put a 0 there. So it is
120.
yes. Let's try another one here. What is 90 times 4?
90 times 4.
So first do 9 times 4.
That is 9 times 4. It is 40. No, wait, 36.
36, good. And then this 0 comes down with it.
360.
Yes. Okay, so let's try a couple more here. What is 70 times 5? Try that one on your own, please.
Times 5. 35.
Give me the final answer.
Um, 3, 330,
I'm sorry, you said 300 and 300 and what?
35? No,
335. But every other problem we did had a 0 at the end. 0, 0, 0, 0. Of
wait, can I go back to the problem?
course.
So 7 times 5, it's it's 35 and a 0.
Then you put a 0 at the end. So how do you say this number?
350,
You can say that, but we would rather say 350.
350.
Yeah.
Yeah.
Okay. Let's try another one here. Let's go. Let's go 20 times 7.
20 times 7.
Yes.
So 14. Well, 4.
I want the final answer. Final answer. Take your time and work through it the way we did the last few problems.
140.
Good. Let's try another one here. How about 60 times 5?
Times 5. 6 times 5. 6 times 5. 300.
300, perfect. Okay. Now I think you're getting the hang of this. So here's how this idea extends. Okay. So let's say I wanted you to multiply 30 times 40.
30 times 40.
What you're going to do is you're going to multiply 3 times 4. What is 3 times 4?
12.
12. And then for each 0, you put 1 next to it.
Oh.
So let's try something else. Let's try 50 times, let's go 70. So you're going to, so you do 5 times 7,
35.
35, and then each 0.
2 zeros on the bottom.
That's right. Now, this one right here can be, you can say it a couple of different ways. You can say 1,200.
1,200.
Okay, or you can say 1,200.
1,200.
Either is okay.
Okay.
This one down here would be 3,000.
3,500.
500. Or you can say 3,500.
Oh, okay.
Okay. So let's have you try one here. What is 90 times 30?
30.
And I want you to write the correct answer as well as know how to say it. So take a moment here to figure this out.
Okay. 2,700.
That's correct. 2,700. Okay, so that's good. Let's go back to the questions that you were, what we were started with here. So let's say, and I did message your dad. I've not had a response yet, but I don't know if you have access to email, but or chat. You can always send it through the chat. Any pictures you send me, we can look at. So let's look at another problem here. Let's say you want to make an aquarium, and your aquarium is 30 inches, and then the side is 15 inches, and then the top, let's go 10 inches. Okay. So to find the volume, you take the base times the width, or length times width times height. Let me actually use that language, length times width times height. Okay, so you have to multiply three numbers together, 30, 15, and 10. And the truth is that it doesn't matter the order. You could actually do like 30 times 10 first.
Mhm.
You could do 15 times 10 first. Or obviously you can do 30 times 10 first. It doesn't matter. So which one are you gonna do first? You're gonna do 30 times 15, or are you gonna do 30 times 10 or 15 times 10? Which one are you gonna do?
30 times 10.
Okay, so you're gonna go down this road. So we're gonna rewrite it. It's 30 times 10 times 15. Okay, so tell me, what is 30 times 10?
30 times 10 is 3.
I'm sorry?
3. Wait.
The number gets larger when you multiply. So try again.
Um, 10. So it's oh um 3. Oh wait, what's 3 times? It is 70.
Okay, let's go back up to some previous problems here.
Mm-hmm.
How did we do 30 times 40?
We multiplied 3 and 4, and
Okay,
then we did 12. We made 12, and then we put 2 zeros on the bottom.
great. Now I can't see what you're doing, but what I hope you would be doing is writing 30 times 10 like this, so that you can multiply it.
Okay. Um. 700.
Okay, again, let's go back. What did you do in this problem? You multiplied 3 times 4.
3 times 4, yeah.
Okay, so what should you multiply here?
Oh, it's 3.
Okay, keep going.
300.
Okay, so it's 300.
Uh-huh.
That's fine. So it's now 300 times 15. Okay, so 300 times 15, you can really do 3 times 15, okay, or 15 times 3, and then add these zeros at the end. So what is 3 times 15?
Um. 45.
Okay, so then you have 2 more zeros. They go at the end here. So what is the final answer?
4.
4,000.
4,000.
500.
5,000.
500. So you would say 4,500.
100.
Okay, so let's just work on we'll just spend a little bit of time here working on how to say the numbers. So let's tell me how you would say this number here.
3.
1,000. Yep, 3,000. Okay, what else?
100.
I'm sorry. What goes next?
3,600.
600. Good. Okay. How about this one right here?
850.
850. Good. Okay. How about this number right here?
4,000 and 200.
Good. Good. Excellent. Okay. So now last one here. How about this one? How do you say this?
1,500.
Good. Good. Okay. So let's go back to our problem here. We're going to go, here's another rectangular prism. This time it's 20 inches. This time we're going to make it very different. This one's 30 inches. Okay. And we'll make this 5 inches here. Okay. So I want you to find the volume. And from your notes or from earlier in the lesson, what is the formula for volume? What do you multiply?
We multiply 20 and 30.
Say that one more time.
20 and 30.
I'm asking for the formula. I'm asking for the words. Like how would you describe the volume to someone that doesn't know math? Look at this problem here. What is the formula that we used?
Length and
Times length times width times
height.
Yes. Okay, so it's the same formulas. It's the volume formula is the same. It's the length times the width times the height. Okay. So which number is the length?
The 20.
Okay. What is the width?
5.
Okay. And what is the height?
30. Oh wait, no. Can I change it or no?
Sure. The answer though is it doesn't matter because you have to use all 3 numbers. But yeah, you can change it. Well, how do you want to change it?
The height 5.
Okay. Width is.
And then the width is 30.
Okay. Great. So now I want you to multiply 20 times 30 on your own, please.
Okay. Six
600. Okay. Times 5.
Times 5.
So try that.
Six. $6,000. Hi, 6,005.
Nope. It seems like there's just this disconnect here. You're going to do 600 times 5. And we talked about multiplying 6 times 5 together?
6 times 5 is 25.
Nope.
Um,
I can't tell you because the whole point of this is just something you've got to know. So 5 times 5 is 25. That's for sure.
also, we're doing 6 times 5.
Yes.
So I can't like change it, like instead of the 5.
No, you have to do 6 times 5, and that's what we've got here.
Okay. 12, and then
Okay, 6 times 5 is 30. And then you put the 2 zeros down there with it. So it's 3,000.
okay.
Okay. So the answer is 3,000 inches cube or cubic inches. All right. So that does take us to the end of our part of the lesson for today, Zoe. I'm going to admit Michael and get started with him. So thank you so much.
Thank you. Sorry, I kind of
Nope.
make my mistakes.
No problem. You did great today. See you next time. Hey, Michael, how's it going?
Good.
How you have not started school yet, is that correct?
Yeah.
All right. Well, what would you like to work on today? What kind of math stuff would you like us to talk about?
I would like to work on my 5 place.
Can you give me just a little more words, please?
I want to work on my 10s and 5s.
Okay, so we did that last time. We did some tens, rounding. And let's do some review on that. And then we'll try for some 5s, although 5 is less common. So let me give you some problems here. 67 and then 34. What do you recall what either of these round to when you go to the tens place? Can you tell me from last time what you remember?
So 67 rounds up.
Okay, to what? What number does it round up to?
70
Okay, and how about 34?
stays the same.
Doesn't stay the same. It's got to go down to a number with a 0 at the end.
30.
30, good. Do you remember the rule? Like, why does this one go up and why does this one go down?
Because 1, 2, 3, and 4 rounds down. Or
It's actually 0, 1, 2, 3, and 4 that round down because that 0 is a case. What round up? What numbers round up?
5, 6, 7, and 8, and 9.
Yes, perfect. Okay, great. So I also mentioned last time that there are some things that I can do to be distracting. Like I could ask you what 61.9 rounds to, and what is the only digit that you care about? Do you remember which place it is?
The 10s place.
The ones place. The ones place. So you just look at this number here. So does this round up or down based on the 1?
Down.
Okay, so it rounds to what number? 6 followed by a
600.
by a 0.
Oh, 60.
Yeah, you don't even you really don't even care what this is ever. You just ignore it. Okay. All right, so let's try another one. How about 72.3? What does it round to?
It rounds to 880.
Yeah, you gotta be really careful here, right? You gotta say the right word. So it either goes up to 80 or down to 70. Now, which you look at the ones place. What digit is in the ones place?
The 6.
Are we looking at the same problem here? Isn't that one in the ones place?
No.
Okay, the ones place is to the left of the decimal. This is the ones place. This is the ones place. The 7 is in the tens place. The 3 is in what's called the tenths place. So you only look at the number that's in the ones place. That's how you decide. That's how you decide what to round to. So does 2 round up or down?
Up.
But you just told me, Michael, you said 0, 1, 2, 3, and 4 rounds down. So do you believe this, or is this still not clear? Because you said this and this was totally correct. So you look at the ones place. The ones place is just to the left of the decimal. If there's no decimal, it's the first number you see. Okay, so does 72.3, does it round down to 70 or up to 80?
Down.
Yes, it rounds down to 70. Okay, so let's look at another one here. How about 46.01? Okay, which number is in the ones place?
The 6.
The 6. Does that mean it rounds up or down?
Up.
Up. Now the number we look at to decide to figure out what the numbers are, see this 4, this is in the tens place. So that 4 means it either goes to 50 or it goes to 40, but it's based on this 6. So which one does it go to? You already
50.
said it, 50, perfect. And see all of this other stuff, this is all a distraction. It's all a distraction. Okay, so let's try another one here. How about 99.9? What does this round to? And you have two options. Either it goes up or it goes down. If it goes down, it's 90. If it goes up, what is the next 10 up from 90?
100.
Okay. So what does this round to?
100.
Rounds to 100. Good. Okay. Now this was another kind of thing last week that I guess was unclear. And I hope to clear it up now with you. What does 8 round to? 8. Does it round up or does it round down? And remember, it's to the nearest 10. So the nearest 10 is 10, 20, 30, and so on. But there's also one going the other way, which is 0. So does 8 round to 10 or to 0? And before you answer, which position is the 8 in? Is the 8 in the ones place?
Yeah.
Yes. So does it round up or down?
Up.
Up to 10. Let's say I gave you a number like 3.4. What would that round to?
0.
0. Good. Okay. Time to try some on your own here. I'm going to give you 4 problems and I'm going to see what you've got here. So let's go 67.1, 92.3, 5.1, and then one more here. Let's go 70. All right, so take a few minutes and see what you come up with, please.
Okay. I'm done.
Okay, what did you come up with for the first one?
70.
How about the second one?
90.
Okay, next one.
No, 5 or 6.
Okay, so all of the answers we've given so far, they've had a 0 on the end. 0, 0, 0, 0, 0, 0, 0, 0, 0. Do you see the pattern? They all go to, there's got to be a 0 at the end. So this can't round to 5.
10.
10. Okay, and how about the next one?
70.
Perfect. Very good. Very good. Okay. So you tell me a little more about the rounding to the 5s. Is that something that you've been seeing in your math practice or something from school?
No.
So where did that come up? Because it's a little bit odd to round to the nearest 5. So I just want to make sure that that is truly something you want to cover.
Okay.
Is that true? You want to round to the nearest 5?
Yeah.
Okay. Okay. So it's kind of the same thing, but I think it's more complicated. And I that's why I asked if you really want to do this. Let's take a number like 23. Okay. So before we even figure out what this could round to, let's start writing out all the 5s now. 0, 5, 10, 15, 20, 25, 30, 35, 40, and so on, right? So what you have to figure out is what are the ones that are around your number. So there's one that's smaller and one that's bigger.
The one that bigger.
So the answer in short is that is the correct answer. So now here's another way you can do it. You can take both numbers and you can subtract. Show you how you do this. You subtract, but you always want to have a positive number. So 25 minus 23 is 2. 23 minus 20 is 3. Okay. Which means that it's closer to 25, which is why you gave me that number. Okay. So let's try another one here. How about something like 71? And it could either go to 75 or 70.
70.
70, okay. Now you try one. How about 36? What does that round to?
40.
Well, it could, right? There's 35 and then there's 40, but which one is it closer to? And if you're not sure, you subtract here. 36 minus 35, 40 minus 36. Which one is it closer to?
The 5. 35.
35. Let's try another one here. How about 49?
It goes to 50.
Goes to 50, yeah. How about 32?
It goes to 30.
Good. How about 66?
Goes through 65.
Yes. Very good. Okay. All right. Let's see if I can find. Okay, now let's try some single digit numbers. What does 4 go to? 4.
It goes to 3.
It's got to go by the 5s, 0, 5, 10, 15, 20, 25, and so on.
5.
Goes to 5. How about 17?
It goes to 18,
I'm sorry,
20,
goes to 20. Okay. How about 99?
it goes to 100.
All right. So now we're going to do some 3-digit ones. Okay. So here's a 3-digit one, 123.
120.
So there's two options, right? 120 or 125. Which one is it closer to?
120.
So the way you do it is you take 125 and you subtract 123, or you take 123 and subtract 120. You take the bigger number and subtract your number, and then you take your number and subtract the smaller number. Which one is it closer to?
125.
Yes. Okay. So how about 276?
It goes to 280.
So it either goes to 280 or 275.
280.
So what is 280 minus 276? How far
200.
apart are they?
Ten.
Nope. 280 minus 276. How far away is 76 from 80?
$78.
Okay, you're just guessing. All right. Let's go back. Okay, so let's just look at something here. What is 40 minus 37? Do you know how to do that problem?
No.
Okay. How so you're not sure how to subtract 2-digit numbers. Okay, so like have you seen this borrowing technique?
No.
Okay. How do you add two numbers like this? Michael, how do you add these?
I don't know.
Okay. So you've not seen 2-digit addition before, is what I'm hearing. Okay. All right. How about something like this? 9 plus 7. What is that?
$15.
Okay. So nine is, I mean, there's a lot of ways to do this, but one way is to say that seven is really 1 plus 6. And then 9 plus 1 is 10. 10 plus 6 is 16. Okay, let's try something else here. How about 8 minus 3?
5.
5, okay. How about 8 plus 3?
10.
Okay, so like I look at 8 plus 3 and I think of it as 8 plus, and then because 3 is really 2 plus 1. 8 plus 2 is 10. 10 plus 1 is 11. All right. Okay, Michael, I think this is actually probably a good place for us to stop today. I think there's some work that you're going to want to do this week, working on some adding and subtracting. So I'm going to just recommend that to your dad. I'm not sure if he's around right now, but
Yeah, I'm right here, Matt.
hey, so yeah, we ran into a little bit of a roadblock here with Michael. These are some things that I definitely want him to be really strong at. We really can't move forward in a lesson like this until he can do, start off with 2-digit stuff and we're moving down to 1-digit. He's got to be really strong at, 1-digit adding, subtracting, multiplying, dividing, and there's just no substitute for just a lot of practice. And I don't even think that there's learning. I think it's more memorization. I think it's just like you see it over and over and over again. You're like, okay, I know how to do this. I know this is
Right.
because we're at kind of a standstill here. We can't work on some of this other stuff. It occurred to me right away that Michael's really struggling with how to compare these two numbers. But if this isn't clear and this isn't clear, there's just no way to move forward. So
Yeah, that's the fundamentals essentially.
yes, and it's no big deal because there's plenty of time to figure this out. There is a lot of practice that needs to be done. Now, in case of Zoe, I'm not sure if you were able to see any of her lesson. We were able to do some two-digit work in terms of volume. I'd messaged you because I wasn't sure exactly what you wanted to work on. If you can, please, either text or email over in advance. It really helps me to know what they want to work on. You can if it's a worksheet or if it's just something on it, just something to kind of initiate the lesson to really be.
I get it. That makes a lot more sense. That saves some time from when they literally start with you.
I have students that they wait until the lesson starts, but you can fire it off to me at any time. I mean, I'm gonna have it and capture it because it's for them. It's like, what do they want to work on? So, do you have any questions for me or anything you'd like to talk about?
Well, no, just in terms, Michael, I get it. He needs to work on those addition and subtraction. What about Zoe? What does she need to work on?
So she would benefit from doing 2-digit multiplication, 2-digit times 2-digit, or if there's more to this volume stuff, she could try on her own. One of my strengths is if I see what they want to work on, I can generate a lot of problems like it that are going to help them to, like replicate exactly what they're seeing and then give them the variations on it. Yeah, I'm sorry, not more helpful here, but we'll get into a good routine with them. Just a little bit more preparation would help me to know what they want to work on.
I understand. I'll make sure to email you some, because what I usually have been doing is making them have some notes ready. Okay. But I guess it would be a lot better if you had those notes before the session even started.
Yeah. And once school starts, just like what either they worked on that week or if they have something due on Monday, just something to kind of like and here's the thing, they get way better at this the more they do lessons. I had a student last year who, beginning was just totally unorganized. By the end, he was like, yeah, I know exactly what to work on. So it really helps. The routine, the rhythm of all that. So yeah, that would be a recommendation. So yeah, thanks again.
No, yeah, it makes sense. They just need to get more practice down.
Yes.
Yeah, practice makes perfect.
It does. It really does.
Yeah.
Okay.
But yeah, we'll work on that, and then we'll also be sending you some notes a few days before.
Sounds good. And let me know if you want us to schedule for this time next week, and I'll reserve it for you guys.
Yeah, most likely. Yeah, if you have it open, we can actually do that right now if you send it.
Yeah, sounds good. I'll schedule it right now.
Okay, Matt. Thank you. Appreciate it.
You're welcome. Have a great weekend.
Thank you.
What's left of it? Okay, bye.